Next, I want to talk about the derivative as a function. So the derivative of a function at a given point gives us the rate of change, or that's the slope of the tangent line to a function at a point. The derivative function gives the derivative of a function at each point in the domain of the original function for which the derivative is defined. So a function f of x is said to be differential at a if f prime of a exists, so if the limit exists. The converse of this theorem is not necessarily true. Just because it is continuous doesn't imply it's differentiable. So let's go through an example. I have f of x equals the square root of x. So I'm going to go ahead and I have f prime of x, my derivative, equals the limit, as in this case, let's have h go to 0, of the square root of x plus h minus the square root of x over h. I need to, because I'm dealing with radicals, I have to multiply by the conjugate on the top and on the bottom. This will simplify down to f prime of x equals h over h times square root of x plus h plus the square root of x. This is the limit as h goes to 0, if I plug in 0, of 1 over because these h's cancel. That gives me 1 over the square root of x plus h plus the square root of h. This h goes to 0, so I have 1 over square root of x plus the square root of x. I have 1 over the square root of 2x. For this next example, I have 3x squared minus 4x. So again, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. So this gives me the limit as h goes to 0 of 3 times x plus h squared minus 4x plus h minus f of x, so minus 3x squared plus 4x, because I distribute that negative all over h. This is going to simplify down to the limit as h goes to 0 of 6hx minus 4h plus h squared, and I can over h. And I can go ahead and pull out a factor of h. Hint, that's going to be something we always do. 6x minus 4h plus, minus 4 plus h all over h. My h's cancel. So I have the limit as h goes to 0 of 6x minus 4 plus h. Well, h is going to 0. So I get 6x minus 4 is the derivative. Next, same thing. I have the derivative is the limit as h goes to 0 of f of x plus h minus f of x over h. So I'm going to get 7x, because I'm plugging x plus h in, so I get 7x plus 7h plus 2, and then I'm subtracting 7x plus 2. Oops. So it's minus 7x minus 2 all over h. Well, my 7x's are going to cancel out. That leaves me with and my 2's are going to cancel out. So I have the limit as h goes to 0 of 7h over h. Well, these 7 h's are going to cancel, so I'm left with 7. Now, the derivative of function is itself a function, right? So we can find the derivative of a derivative. So for example, the derivative of a position function is at the rate of change is velocity. But if I take the derivative of velocity, I get acceleration, okay? This new function obtained by taking the derivative of a derivative is called the second derivative, right? And we can continue to take derivatives until we run out of steps we can do, which I'll show us more of when we go over derivative rules. But like, we can go ahead, and I'm going to let you know that this is just 6, right? So we can find high order derivatives.